Welcome back for the second half of section 1.4. So we're still basically dealing with the same ideas. We're talking about solving equations, and our learning targets are still talking about solving equations and solving problems by writing equations. The difference between yesterday and today, however, is the idea that today we're talking about literal equations. Now, that language itself isn't actually too important, but just understanding that it means you're dealing with equations that use two different variables, okay, that are relating the two variables. And a little equation, what I can ask you to do is solve it for a different variable, okay? So let me show you what that means. So let's talk about this first one. Solve the equation for S. So right now it's P equals 1/3 times S. So to solve it for S, basically what it means is it wants me to get S by itself. Rewrite the equation to isolate S. So it's basically S equals something. Okay, now P equals 1/3 S. So you're probably saying that 1/3 is multiplying the S, okay? So you could see this as I need to divide by 1/3 to undo it because it's multiplying the S, right? And that would get you to the answer just fine. However, I do think that that's a little bit more complicated than what you need to think about. So if you think about multiplying by 1/3, well, can't you just multiply both sides by 3 and that'll undo the 1/3, right? Because 1/3 times 3 is 1. So for some of these, there are multiple ways you could go about thinking about it. Here, dividing by 1/3, there's nothing wrong with it. I just think it's a little bit extra work where you could literally just multiply both sides by 3 and solve it that way. Okay, so just be cognizant of some of those tricks of the trade so you're not putting extra work on yourself and making things harder than it has to be, okay? Because that shows up quite a bit. We could just multiply by something instead of dividing by a fraction, all right? Or what about this one? Okay, solve for k. So I want to get the k by itself. So what that means, first and foremost, anything else needs to be moved to the other side, okay? So this 2z, I need to add over. So that's going to be the first step, okay? Is doing that. Now, after I've moved everything else over that doesn't have a k, now I'm going to divide by 6. All right, so now that gives me k equals, well, 12 divided by 6 is 3. 2 divided by 6 is 1/3. So you can write it like that. Okay, so again, not too complicated, just making sure that you remember the steps necessary to get to where you want to go. All right, so now this next one, like I said, sometimes there are multiple ways to get to a solution. All right, so I'm going to show you both of the ways to get d by itself in this case, okay? Now, first way, I think a lot of you see this side of the equation and you immediately think, all right, distribute. So 5r squared plus 5d equals 10. I'm trying to isolate the d. I'm trying to get the d by itself. So I'm going to subtract off the 5r squared. Okay, remember you always want to move the other things away. So 5d equals 10 minus 5r squared. Divide by 5. So now d equals, well, 10 divided by 5 is 2. Negative 5 divided by 5 is negative 1. So you get 2 minus r squared. Okay? So again, I think that's probably what most of you would see. However, I do want to implore you that there is another way you could think about this, okay? So it doesn't matter which way you do. I just want to open your eyes to this idea that there's multiple ways to do this, okay? Notice this 5 and 10, okay? What if I divided by 5 right away, okay? Since it's sitting out front, it's multiplying the whole thing. I could just take care of that 5 first. Everything's being multiplied by 5. Let's divide by that 5. So I'd be left with r squared plus d equals 2. Now, still need to get the d by itself, so I subtract r squared. So d equals 2 minus r squared. And you end up getting exactly the same thing. So again, just be aware of those multiple ways, okay? In this case, I really don't care which one you do. If you recognize one or the other, if you recognize both, awesome. Just make sure one of those makes sense to you though, okay? All right, well, let's talk about this one. Solve the equation. Oh, that should not say y. Solve the equation for t, or no, sorry, it should say y. I apologize. All right, so solving the equation for y. All right, now notice in this case, this t is dividing the whole thing, okay? So what that means is I really do have to deal with that t first. It's dividing that whole side of the equation. It needs to be moved first, okay? So let's multiply both sides by t. When I do that, I get y plus 3 over here. Now over here, we're going to have to remember our rules of exponents. So t squared times t to the first. Remember, when you're multiplying, you add exponents. So this is actually going to be t cubed, okay? So in all those little things that we learned back in Expo are going to periodically come back up again in Algebra 2, okay? So now finally, to get y by itself, I'm going to want to subtract the 3, so I get t cubed minus 3. All right, moving right along. So there is a more complicated situation that can arise, okay? So what if you're asked to pull out a variable that appears multiple times in the equation? When that's the case, you're going to have to factor or you're going to have to pull it out, okay? So basically, think of this pulling out. That is basically the reverse of distributing. Okay, that's essentially what I'm doing here. And again, you've seen this before, but this is just a good chance to bring it back up again. So in this first one, solve for x. But I see x multiple times. So what that's telling me is I'm going to have to pull it out. Whenever the variable is represented multiple times and you're trying to solve for it, you're going to have to pull it out. Okay, so when I pull it out front, I'm left with an a minus b left in parentheses equals c. And notice this should look right to you, because think about distributing that x in, you would get back that original equation, okay? So quite literally, you are just reverse distributing here, okay? Which is called factoring. Well, now I want the x by itself. Well, the x is being multiplied by that a minus b, okay? So I need to divide both sides by that a minus b to get it away from the x. So my answer is going to be c divided by the a minus b. That is what x is going to equal. All right, what about this next one, solving for u? So solve for u, same thing. I see u on multiple or in multiple pieces. Now this time it's across the equal sign. The only way you can factor, you can reverse distribute, is if it's on the same side of the equation. So first thing I'm going to do is I'm going to add TU to both sides. Because you do need those u's together in order to factor them out, okay? So once they're together, now I can factor it. And now finally to get the u by itself, I'm going to have to divide by that v plus t. And I'll end up with that. Okay, so again, you may even want to make a little side note, because I didn't write it down here for you, that you do always need that variable to be, you need to collect all of them on the same side before you factor them out. All right. Now, let's kind of dive into some more real world-ish examples, okay? Because right now we've been dealing with very abstract ones. Let's talk about some real life examples, and some really good ones are based on temperature. So there's 3 temperature scales: Fahrenheit, Celsius, Kelvin. So obviously there have to be equations that relate them to one another. So here is my equation. Kelvin is equal to, if you take the Celsius and you add 273. And now it's asking for what is C in terms of K. When you see that, what is C in terms of K? What that's asking for is solve for C, okay? And when you solve for C, you're going to have it in terms of the K, all right? So I have K equals C plus 273. Well, if I'm trying to solve for the C, let's subtract off that 273, okay? That'll help get the C by itself. So I'm going to have K minus 273 equals the Celsius. And there, I already have my answer, okay? Now, what about between Fahrenheit and Celsius? This one is a little bit harder, okay? So, let's talk about this, F in terms of C. So again, what that means is solve for F, because when you do, it's going to be in terms of C, all right? So I need to think of getting the F by itself. Now, notice this 5/9 out front, okay? So kind of like back here, where was it? Where on the blue side, I dealt with that 5 first. That's what I'm going to choose to do here, okay? But I'm going to multiply the 9 over and divide by the 5 to get rid of it, okay? So I multiply the 9 over, divide the 5. Now I don't have to worry about distributing in a fraction. If you did distribute it, that would be totally fine. There's nothing wrong with that. But I think it'd be hard to distribute in a fraction. It wouldn't be that user-friendly to us, okay? Now I still have to get F by itself, so I'm going to add 32 to both sides. So I'm going to have 9/5 C plus 32, and that gives me a way to find Fahrenheit in terms of Celsius. All right, so that is going to be all for our notes today. So again, make sure you take a moment here, write your summary for me. Now, there was at least one time in here that I recall mentioning, hey, write a side note about this because I didn't write it for you. That would be a great opportunity to include that in your summary because it's not actually written in your notes for you yet. So, but again, anything you want to write, make sure you just include that summary for me. Come back ready to do your practice work.